Dear students, myself Vikasa, and I am here to start with the class of differentiation. And this is from the very basic to the higher level. In the first videos, the first 2 to 3 videos, I will just explain you about the differentiation, how it is done, and what is the geometrical concept behind this uh, whole differentiation. Okay, the first thing is we have to go with the basics of some differentiation parts. In the differentiation, what we have to deal with, we have to just know some basic concepts, basic formulas. Furthermore, there is a method to derive the formulas for that, and that method is about the first principle method. Okay, today I am just going with the formulas direct, and in case I will just do a video which will explain you about the first principle in the later classes. Okay. Now here in this class, this is the topic of differentiation, and I am here to explain you the topic of differentiation. We will do some of the basic questions. This is the very first question, and I am here to explain you about the differentiation. The first formula here lies with, this is d by dx of x raised to power n. Here it means n x n minus 1. This is a basic general formula for the differentiation. Okay. In this case, what you will be having is that if you are having d by dx of x raised to power 7, then the differentiation of this is 7x raised to power n minus 1, which is 7 minus 1, and it will give you 7x raised to power 6. Okay.
Recording in progress.
Now here in this case, we are having something different. Now here the thing is, and if we are going with another method, that is the sorry, not method, the question. Okay, the first question. Question number 2 says you are having d by dx of x raised to power 12, and you will be having 12 x raised to power 12 minus 1, which will give you 12 x raised to power 11. Okay, in this way, you are able to do some of the questions. These are the basic questions which you can easily do. For example, if I'm having a question like this, that d by dx of 7x raised to power 5, well, how you will do this? In this particular question, the 7 is a constant number, it will come outside. And what it means that you have to differentiate d by dx of x power 5. What it will give to you? It will give you 7 times 5x raised to power 4. Okay? These are the basic methods. If you, here, you can do one more thing. For example, if you have to find out the d by dx of x raised to power half, it is, you can say 1 over 2 x raised to power half minus 1, and it will give you 1 over 2 x raised to power minus half. Furthermore, it will yield 1 over 2 x raised to power half, and furthermore, you will be having twice 1 over twice root x. What is this? This is d by dx of under root x. This is the whole thing. Okay, this is the main thing, and this is the whole thing. This is, you can use it as a general formula of anything which is inside the square root, which is equals to 1 over twice root x. If you are having a thing like this, d by dx of x raised to power 3 over 5, then 3 over 5 will come forward. You are having x raised to power 3 by 5 minus 1. You will be having d by 3 by 5, x raised to power minus 2 over 5. Furthermore, 3 over 5 and x raised to 1, 5 raised 5 times x raised to power 2 over 5. Okay, and this way you are able to do the questions. If you are having a question like this, you have to find out the d by dx of x plus x squared plus 5x whole square. What you can do? You can simply do the a plus b whole square. It will give you a square plus b square plus 2 times a b. It will give you x raised to power 4, 25 x raised to power 2 plus 10 x raised to power 3. In this, what you can do is now you have to differentiate this. Now you have to differentiate this. What it means, you have to write down the sign of d by dx as you have put in the question. Now x power 4 means d by dx of x power 4. Here, this is 25. 25 will come in the forward place, and there will be d by dx of x squared. You can write it 10 times d by dx of x cubed. Now here, x power 4 is what? This is 4x cubed. 4 will come in front. Then x raised to power 4 minus 1, which will yield you 4 minus 1 is 3. Now here, this is 25 x squared. It will give you 2x plus 10 times 3x squared. Okay. Now in this form, further the answer will be in the form of 4x cubed plus 50x, okay, plus 30x squared. You can change the order. You have to first put the cube, then the square, and then x. And in the last, if here would have been, you can put the constant. Now, there are some more questions, more methods. Now you can say d by dx of e raised to power x. It will be always equals to e raised to power x. There is no change in this. If you are having d by dx of e raised to power x, in the upper part it was e power x. Now here this is e power x. It will give you a power x log a. Further, if you are having d by dx of log x, it would be equals to 1 over x. Okay. E power x is equals to e power x, e power x equals to e power x log a, log x is equals to 1 over x. Clear? If you are having anything which is set to be a constant, but this is be a, and a is not having the power in the function x, and it is always equals to e. Anything which is constant, will be having the power 0. Oh, sorry. Well, anything which is constant, when we differentiate it, it will be equals to 0. Okay. There are some more formulas to it, and those formulas are somewhat in the form of, if you are having, now we are having some more things. We are having some more things, some more formulas. And the formulas for trigonometries are, first, you can see this is d by dx of sine x is equals to cos x, and d by dx of cos x minus sine x, d by dx of tan x sec square x. These are the formulas. Now, some more formulas are there. Dy dx of what you call as cot x minus cos x square x. Dy dx of sec x tan x. Dy dx of cosec x minus cosec x cot x. It means cos x minus sin x, cot x minus cosec x minus cot x. The sign cos with the c, anything to start with c gives a sign in negative on differentiating. These are the simple basic rules. And now let's move on to the next topic. And the next topic is what? We are having the questions. We will do some of the questions here. Okay. If we have to do some of the questions, then the first thing is, now we have to go with some of the questions. The first thing is about the product rule. This is product rule. Now, what the product rule says? The product rule says that if you are having the two functions, that the one is fx and the another one is gx. The first is fx and another one is gx. Then the formula for this is, first you have to put gx as it is, and you have to differentiate this first part, which is fx. Plus not equals to, this is the sign of plus. Fx will remain as it is, and you have to differentiate gx. Okay. At one point, you have to differentiate the first function, others will remain as it is. And in the second step, and the plus with the plus sign, you have to put the first function as it is, and you have to differentiate the second part, which is gx here. Now, if you have to go with an example here, this is example number 7. If you are having d by dx of x raised to power 9 times sine x. This is x raised to power 9 sine x. Here, x power 9 is the first function, whereas the sine x is the second function. Now, what we have to do is, we have to do in accordance with the formula. In the formula, what we are given here is, the first part is gx. It will remain as it is. Here, the gx is sine x. So I will put sine x as it is. Okay. Then I have to differentiate the first part, which is x power 9. Now here I will be having d by dx of x raised to power plus. Then comes fx. Fx is x power 9. I don't have to differentiate it now. The differentiation of x9 is not taken in the care. And I have to differentiate the second part, which is d by dx of sine x. Okay. In these two methods, I have to do this. Now, sine x will remain as sine x. Whereas, if we differentiate the x raised to power 9, which we have already done, it will give me 9x raised to power 9 minus 1. Plus, x raised to power 9 will remain as it is, and I have to differentiate sine x, which will give me cos x. Okay. Now, in the second step, what I can do is, this will become sine x times 9x raised to power 8 plus x power 9, and this is cos x. Okay. Now what it will give me, if I could take x raised to power 8 common, it will be equals to 9 sine x plus, and x power 8 is common outside, it will give me x cos x. This is the example of, okay, I'll do some more questions. Here, in this case, if you are having the question like this, d by dx of log x into e raised to power x. Now function is log x times e raised to power x. I can take any to be fx and the remaining to be the gx. If I am taking log x as fx, this is the first function, fx This is the second function gx, and I am just applying the product rule. Okay. Now here, if I apply the product rule, the ex, the second function, will remain as it is. Now I have to differentiate first function, which is d by dx of d by dx of log x. Okay, gx as it is, and you have to differentiate the second function, where you have to differentiate the first function, which is log x fx. Then log x will remain x as it is, which is the first function, and I have to differentiate the second function, which is d by dx of e raised to power x. Now, e raised to power x will remain as it is, and log x will give you 1 over x plus log s as it is, and I have to take ex, and ex will remain as it is because we know that the differentiation of e power x is e power x. Now, what I can do is I can take e power x as common. In the bracket, I will be left with 1 over x plus log x. You can leave the question, give the answer here. As if you want to do some more simplification to the answer, and it can be rewritten as, if I take LCM here, it will give you 1 plus x log x, and in the denominator there will be x, and I will take this x out. It will come just below the e power x. This is the required answer. I can do one more question to this. For example, if you are having a question, let this be a question such that d by dx of mod x, and the function is let there be a power x. These are the two functions, mod x and e raised to power x. Mod x is acting as a fx, whereas gx is e power x. And the first thing is I have to put ax as it is because ax is a g power x, ax is a gx, and I have to put a format like writing out d by dx of mod x. Okay. Now, in the second part, the cortex will remain as it is, and there will be d by dx of e raised to power x. This is the first thing which you have to do if you are applying the what we call as the product. This is the first thing. You don't have to do anything else in this case. Okay. Now e power x will remain as it is, and here what will happen? Here what will happen? It will be like this. You have to differentiate cortex. You have to differentiate cortex, and while differentiating cortex, we know that the cortex differentiation of cortex is equals to minus cos x square x plus this is cortex, and e power x is e power x log. This is the complete method of and differentiation of this whole problem. What else we can do now? We can take a power x common from these two parts, which will give you the result as a power x. In the bracket, you are having minus cos x square x plus log a and cot x. This is the required part. Okay, this is your answer. Now we are having some more questions of the product rule d by dx of x minus sin x times log x plus a power x. Okay. Same. This is fx. This is gx. You can do like this. One more thing you can do here is you can just multiply the brackets first, and afterwards you can do the differentiation. Okay. It is up to you. Now here the gx is log x plus e raised to power x, whereas the fx, which we have to differentiate, it is x minus x. Okay, plus x minus sine x is here, and you have to differentiate d by dx of log x plus a power x. Okay, now log x plus a raised to power x, and here if you differentiate x, you will be having 1. Difference sine x, this is 1 minus cos x, plus x minus sine x will remain as it is because this is a g part. Now it is a fx part, x minus sine x. And you have to differentiate the part which is inside this. And log x is 1 over x, and a power x is a power x log a. And this way you can also do this. Okay, now it's up to you if you want to multiply them in the brackets like this to this to this to this, and same here, or else don't want to do all these things, you can leave here. Okay, one more thing I want to tell you in this case only, if you're having the three variables, for example, if you are having d by dx of fx, gx, and the hx, you're having three functions, fx, gx, and hx. In this case, you have to take the same approach here. And the approach is that gx and hx will remain as it is, whereas you have to differentiate d by dx of what we call fx plus fx and hx will remain as it is, and d by dx of gx. Okay, you do have to differentiate a particular function on the very first attempt, then second, then third, and the other two functions will remain with that function, which is just to be differentiated in the form of multiplication. Here you are differentiating fx, and gx hx are remaining as it is. Here you are differentiating gx, and other two are remaining as it is. Thirdly, here you are having fx gx, and you are having d by dx of hx. This is the whole thing which is to be done here. Okay, now let's go with an example. This is question number 11. You are having d by dx of, okay, where is the gone? Okay, what happened to this? Just wait here. Just wait. Now, you are having a function like d by dx of a power x times sine x times log x. Okay, you are having three functions with you. Now, in accordance with the formula, you have to put sine x, log x, and then d by dx of e raised to power x plus. In the second attempt, you have to put e power x, log x, and d by dx of sine x. And the third case, you have to put a power x, sine x, d by dx of log x. These are the three forms which you have to put. Okay. Now we are here to differentiate all these things. You are having sine x times log x times a raised to power x log a. This is the first part which you have to do. You have to simply differentiate a power x only, and the other two will remain as it is. Like these two will remain as it is. Now, plus. There are two parts which will remain as it is are a power x, log x, and you have to differentiate sine x, which will give you cos x. Clear? Next, you have to put a power x and sine x as it is, but there is no sign of differentiation with this. And you have to differentiate log x, which will give you 1 over x. Okay, and you can differentiate. You can take common. You can take a power x common, and you can't take anything else common. Now here you will be having log A, sin x, and log x in the first part. Sin x log x plus log A, multiplied by log A. Plus, here in the second case, this is log x and cos x. Yeah, this part, this part. And in the third case, you are having sin x over x, and the bracket is closed. In this way, you can do the questions which are based on the product rule for the three functions. Now you have drawn a pattern here. Now, as many functions as there can be, you have to just do the simple rule. You have to differentiate the first function, you have to put other functions as it is. Plus, you have to differentiate the second function, you have to put other functions as it is. And in this way, you can go to the nth functions, n functions. Okay. Now, just go on to the third case, second method, which is said to be the method of quotient rule. This is quotient. In the case of quotient rule, what you can do here is this quotient rule is same as the product rule. For example, if we are having a quotient rule as d by dx of fx whole over gx. Okay, in the quotient rule, they are in the fraction form. Now, what I have to do is I have to just put the same thing here as I have put in the product rule, g by x, gx d by d of fx. Okay, plus fx d by dx of gx. Now here I have to do two things. The first thing is I don't have to put the sign of plus. Okay, I have to remove this sign of this is quotient rule. Okay, and here I have to put the sign of minus, negative. And another thing is in the denominator I have to put gx whole square. These are the two things which I have to put. Now let's go with an example here. In an example, I can say that d by dx of log x over sin x. Now here, log x is fx and sin x is gx. What I can do here, I have to put sin x as it is. I have to take d by dx of, which is log x, fx, and then there is a negative sign. Log x will come as it is because it is fx, same, and I have to differentiate the denominator, which is gx. On differentiating this, I will be having sin x, and this is whole square. Okay, sin x d by dx of log x minus log x d by dx of sin x, and in the denominator I will be having sin x whole square. Now the sin x will remain as it is. I have to differentiate log x, it will come to be 1 over x. Now here minus log x, and then the sin x will give you cos x. Okay, and in the denominator you will be having sin x whole square. You can do LCM of this, and by doing the LCM, I will be having sin x minus x log x cos x, and in the denominator, this x will come here, and you will be having sin x whole square, or you can write it as sin square x. Okay. Now we shall do some more questions here. If we are having the d by dx of what we call it as, just take some of the other examples, which is e raised to power x, and over you are having 10x. Okay. Same thing, 10x will come as it is, and I have to differentiate d by dx of e raised to power x. Then I have to put a sign of minus here, negative sign. Ex will be there, and d by dx of 10x. In whole of the denominator, what I have to put, I have to square the 10x, which is the gx part. Okay, now 10x will remain as it is, and e raised to power will be e raised to power x, because we know that the differentiation of exponent, that is e power x, is e power x. In the second part, e power x will remain as it is. This is fx, and we have to differentiate 10x, which will give us x square x, because we know the differentiation of 10x is x square x. Now, what the denominator will be? Denominator will be 10 square x. Okay. Furthermore, this is 13%. Furthermore, I can take e power x common, and the left one part will be 10x minus x square x, and in the whole is 10 square x. Okay. Let's go on to the next question. This is 14th. And in the 14th question, you are having d by dx of log x over sec x, which is equals to sec square x in the denominator part, and in the numerator part, you will be having sec x and d by dx of log x minus, this is log x, d by dx of sec x. Okay, sec x d by dx of log x minus log x d by dx of sec x, and in the denominator, this is sec square x. Now, what else we can do? We have to differentiate this. This will become sec x times 1 over x minus log x, and sec x will give you sec x 10x. And the denominator, you are having sec square x. Now it's up to you. You can take common sec x in the numerator, as well as you can take the LCM there, and you will be having sec x at the outside. And now let's write it down. Now let's sit down. This will give you sec x. Okay, and the bracket, this is 1 by x. If you do it like this, it will give you 1 minus x log x 10x. Okay, this is in the numerator part, and in the denominator you are having sec square x. Fine. Now this sec square x is 2 times. It will remain to be 1 time after getting cancelled from the numerator. Okay, 1 minus x log x 10x, the numerator, whereas denominator is sec x. Now, if you are having a question like this, you are having d by dx of e raised to power x and cos x, and in the denominator, you are having log x. These are the 3 things which you are having in the question. Now here, first thing is the upper part, the numerator part is fx, the denominator part is gx. We have to simply apply the rule here. The rule says that log x will be as it is, and you have to differentiate d by dx of e raised to power x cos x, whereas there is a sign of negative, you are having e power x cos x, and you have to differentiate log x. In the denominator, there is log x whole square. Okay, log x d by dx of e power x cos x minus e power x cos x d by dx of log x. In the denominator, there is log x whole square. Now, this is log x, and here this is e power x cos x. Now, this is the first one. Now, here you have to apply the product. Okay, where here in this case, first you have to apply the product. Okay, mind it. Many a times students do this mistake. They don't just apply the product rule, they just do their things like e power x is e power x and cos x will give you minus 7x. No, note it. If the 2 functions are in product form, then you have to apply the product rule. Okay. Now here e power x will be cos x will remain as cos x, and if you differentiate ex, it will give you e power x. I'm just straight for applying the product plus. Now ex will remain ex, and if I differentiate cos x, I will be having minus sin x. Fine. This is the thing which I have to do here in the product rule. Furthermore, now here what else I can do here? This is minus e raised to power x cos x, and dy dx of log x is what? It will give you 1 over x. Now I will be having log x. This is whole square. Log x whole square will be here. Now what else we can do here is I can first take e power x common, because this will coming on all the segments, all these parts, ex is there. As well as I can do the differential, to take the LCM using x, because nothing else is coming in the denominator other than this x. Now, first thing is ex is common, and what else will come into the bracket? This is x log x, okay, cos x, okay, minus x log x sin x. I'm doing all the steps. Okay, I am just multiplying as well as I'm opening out the bracket, and here comes the minus cos x. Everything closed. Brackets are closed. Now this x will also come in the denominator because it won't remain here in the numerator part. It will come to the denominator also. This will give you x log x whole square. In this way, you can easily solve the questions of product rule as well as question. But what do you call it? Question. Let us do one more question on the what we call it as question. In this question, we are having this is d by dx of log x, and this is sin x, and the denominator is e power x. Okay, these are the three functions: log x, sin x, whole over e power x. The upper part is fx. We apply the formula. Ax will be ax, and I have to write d by dx of log x sin x minus log x sin x will remain as it is, because now these are the fx, and you have to differentiate the gx part. Okay. Now, in the case of denominator, you will be having the square of different denominator. There's no need, nothing you have to do with the denominator part. It is just the square of the denominator, and the differentiating, nothing doing anything else. Now, in the numerator part, you are having a raised to power x. And now here again, what you see here, you're seeing that you have to differentiate this part. And just don't write it like this, that you differentiate log x to 1 over x and sin x to cos x, and you say that it becomes cos x over x. This will be wrong. Here, these two functions are in the product form. What it means that you have to apply the product rule here. Okay. Now here, this is the product rule which you have to apply here. It will give you, for the log x, it will give you sin x and d by dx of log x. Okay, first function gx will remain as it is, sin x, and you have to differentiate the first function, plus fx will remain outside, and you will be having d by dx of what we call as sin x. Furthermore, this is minus and log x sin x, and I'm just doing it here, the simplification, the differentiation of a power x, and this is log a. Okay, the denominator will go as it is with a power x whole square. Okay, now the second part, what else we can do? The first thing in the second part is I can take a power x common from both the parts. It will give you a raised to power x. In the bracket, you will be having sin x, And d by dx of log x will give you 1 over x plus and log x. Now here, you have to differentiate sine x, and sine x will give you cos x. Not the bracket here, because this bracket has been removed because we have taken a power x common. Now here, this is the negative sign, and it will give you log x, sine x, and this is log a. Okay, in the denominator, you are having ax whole square. This ax will cancel the whole square times at least once. This will be removed. And the question left, answer left is this: sine x over x plus log x plus x minus log x. Sine x log a, you can take the x as the LCM part, you come down and get multiplied with log x, both the parts. Else you can leave it. Okay. In this way, you are able to do some of the many questions of the topic of the differentiation. There are many cases, many things which you have to deal with. Let's do some more question, one more question, not some more question. Let's do one more question. And the question says you are having a function like this is d by dx. So what happened to this? Just wait. Just wait. What happens to this? Okay, now fine. I'm doing the question. This is question number 17, that it says d by dx of sine x minus cos x and sine x plus cos x. Okay. Now here what you can do. The first thing is you have to put the gx as it is. It's a sine x plus cos x and d by dx of sine x minus cos x. And furthermore, this is a negative sign. We're writing down as sine x minus cos x. And you will be left with d by dx of sine x plus cos x. In the denominator, you will be having sine x plus cos x. This is the whole square. Okay. Now, the first part will remain as it is. This will give you sine x plus cos x. And here this is sine x minus cos x. Differentiate it. Now it will give you what? It will give you sine x will give you cos x. And you are having cos x as minus sine x. This minus minus will become plus. It will give you plus sine x minus. Now here sine x minus cos x, this part, it will come as it is. This is sine x minus cos x. And now you have to differentiate this sine x plus cos x. Okay, this one. Now here it will give you cos x minus sine x. It will give you cos x minus sine x. And in the whole of it, you are having a denominator as sine x plus cos x. Now, furthermore, you can put the formula. This is sine x plus cos x whole square minus sine x plus cos x minus sine x minus cos x whole square. And what you will be getting to it, this is what you will be having. This is sine square x here comes, and here comes minus sine square x because of this negative sign. Cancel plus cos x square x here, minus cos square x here. This will again get cancelled. Now here you are having 2 sine x cos x here in this part. Now here in this part you are having minus 2x, 2 sine x cos x, but because of this sine x will come again minus, and you will be having plus. It will give you 4 sine x cos x in the numerator. Only thing which is left is 4 sine x cos x in the numerator. And in the denominator, you are having sine x plus cos x whole square. This is the required part. Okay, clear? Now, let's do one more question. This is question number 18. For example, I think you have done all the basics. You are having d by dx of cosec x, and this is cot x. Okay, very simple question. What it will be? It will be equals to, this is equals to white. This is I'm playing again and again. This is will be equals to cot x, the denominator cot x whole square, and here it will be cot x, and here this is d by dx of cosec square x minus cosec x, and here d by dx of cot square x. Now here this is cot x, and cosec square x is minus cosec x cot x. We know the formula. I've already told you in the very beginning. The cosec, why you have to put the cosec square? There is no need of cosec because this is not a cosec square x. This is a simple cosec x and cot x. Okay, the cot x minus cosec x cot x, and here this is minus cosec x, and here this is cot x, this cotangent x, and cot x is equals to minus cosec square x. Okay, in the denominator there is cot x or cot square x. Okay, now we have to simply multiply them. In the numerator, you can take minus cosec x as common, and if you take cosec x common, just writing it down, cosec x common. Now here this minus and this minus get converted into plus. I'm writing this as first pi. This is cosec square x, this one, and minus from here I'm writing down this cot square x. The denominator there is cot square x. Now there is an identity, and what the identity is? The identity is cot is 1 plus cot square x is equals to cosec square x. That means if I take this down there, it will give to you the 1 minus cot square x. It will give you 1. Okay. Now here what it means? It means that you are having cosec x times 1. And in the denominator you are having cot square x. You can further simplify by converting cosec x into 1 over sine and cot square x into 1 over into cos square x over sine square x. The sine and sine will get cancelled out, and that sine will goes to the upper part, the sine x, and here remains the cos square x. Furthermore, it can be written as 10x, and this is sec x. This is the required answer. What I have done here is I have put cosec x is equals to 1 over sine x, and what I have put on with cot x is giving cos x over sine x. These are the two things which I put. Okay. With this, I am just closing my class today, and these are the very basics of the differentiation topic. Just do more and more questions. I will post some of the questions. Okay, and do more and more questions of these questions. These the differentiation topic, and furthermore in the next classes, I will go by some more things. Actually, I'm planning to do more 2 things at a time. I'm just starting a class series of whole of the class of the calculus. This is a whole class. It will go up till the whole differentiation, optimization, decreasing, maximum, minima, all these things, areas, integration, then definite integration, then areas and the volumes, differential equation. That will go very long. But I will also start a new class there. The new class will be of any other thing which I can start with. I will let you know by the time. Okay, so that you and me both don't feel bored of this. Okay, just enjoy the life. Okay, enjoy and do good work with the studies. Do them good. Okay, bye.